Okay, so today's topic is topic 3. We're going to look at freshwater systems. So specifically, we have surface water that's above ground, and then we have groundwater that is underground. So today's class will just focus on surface water. We'll look at above ground, rivers, streams, lakes, and so on. So first, let's talk about lakes, ponds, and wetlands. So a lake is a large area of water, and it's surrounded by land. One way to differentiate between a lake and a pond is looking at sunlight. In a lake, sunlight will not reach the bottom of the lake. When we look at a pond, it's a body of standing water. It's smaller than a lake. It's still surrounded by land, but sunlight is able to reach all the way to the bottom. All right, so that's one way to differentiate between a lake and a pond is whether or not sunlight is able to reach all the way to the bottom. So in a lake, it does not. In a pond, it does. Clarity, when we talk about clarity, this is the measure of how clear the water is. It's determined by the amount of matter that is suspended in the water. And then wetlands are areas like swamps, marshes, and bogs. They occur in low areas. They are important habitats for many species of plants and animals, and they are usually saturated with water all or much of the time. So here's a lake. This is Lake Minnewanka in Banff National Park. This is a pond, Whiteshell Park in Manitoba, and this is an example of a wetland. And again, wetlands are very important ecosystems. They're important nesting areas for ducks, especially in North America. Okay, so next we're going to talk about streams and rivers. So streams, they are the small, fast-flowing bodies of water, and then rivers are larger, fast-flowing bodies of river. So flowing waters, they're going to differ in speed, temperature, and clarity. They're also going to differ in the nature of their banks and bottoms. So keep in mind they are flowing bodies of water. So different from what we saw with the lakes and the wetlands and the ponds. So all those factors such as speed, temperature, clarity, they're going to have an effect on the types of plants and animals that will be able to live in them. So fast-flowing waterways, they usually are rich in oxygen, which fish and other animals need to survive. We'll talk a little bit about water underground, but we'll talk more of it next class. So underground water, we're talking about water that's beneath Earth's surface. Most of the precipitation that falls on land, it will sink out of sight and go into the ground, and it'll reach this layer here, a layer of bedrock such as granite. So that bedrock layer, it's going to form a barrier. And then when that groundwater cannot move any deeper, it'll begin to back up, and then it'll start to fill the pores in the material above the bedrock. Okay, so freshwater links, the watershed concept. So all fresh water on Earth, whether it's surface water or it's below groundwater, it's part of a watershed. So a watershed, it's also known as a drainage basin. It's an area of land that drains into a body of water, such as a river, pond, wetland, a lake, or ocean. This is a simplified drawing showing a watershed. So then when water hits the ground, it's either going to filter into the groundwater or it will flow downhill. Some of it will evaporate. Water that doesn't soak into the ground or evaporate, but it flows across Earth's surface, that is called runoff. So a watershed would include both water and land, as a variety of habitats, and they range from rivers, streams, lakes, forests, farms, and cities. So next we're talking about the continental divide, which you will also see in that Bill Nye video. So this is, it's a continental divide. So in North America, there's a continuous ridge of mountain summits that divide the continent into two main drainage areas. So on one side, rivers and streams, they flow west to the Pacific Ocean. On the other side, rivers and streams flow northeast, Hudson Bay, or southeast to the Gulf of Mexico. And that's because of that continental divide. Canada has 5 major drainage basins. Most precipitation falling on Canada, it will drain into the Pacific, Atlantic, and Arctic Oceans and Hudson Bay. Some of Canada's river water also ends up in the Gulf of Mexico. All right, so watersheds in Alberta. The upstream areas of a watershed, those are called headwaters. And then the end point of the water that's flowing through a watershed, that's called the outflow. It's usually the mouth of the river. So generally, water that's located in northern and central Alberta will move towards the Arctic Ocean. East, central, and southern Alberta rivers will flow into Hudson Bay, and a small amount of water in the southernmost area of Alberta ends up in the Gulf of Mexico. Watersheds and land use. So the watershed for a storm drain is a city. That's where most of the land is paved over. If the pavement wasn't there, a lot of that water would soak into the soil. If there's pavement, then there isn't that ability for it to be absorbed. It's gonna become runoff. So it would slowly seep into groundwater or flow into rivers, lakes, or other bodies of water. But paving over land, it changes the runoff patterns in watersheds. Logging will also affect watersheds as well. All right, so here, when many trees are cut down, the river's flow pattern will change. Here, what we're seeing when it rains, water, as well as all the pollutants on the land, will drain into ditches as well as storm drains. Runoff and erosion. So whether rain soaks into the ground or it runs off, it depends on the amount of rain and the time it takes to fall. Another factor would be the slope of the land. So gentle slopes and flat areas will be able to hold the water. That gives the water a chance to evaporate as well as sink into the ground. If it's a steep slope, then gravity is obviously going to cause water to run off before much evaporation or seepage can happen. As well, if there's a lot of vegetation like grass, that will also affect the amount of runoff. If it's a smooth surface that it doesn't have very much vegetation, then water will just run off. If there's a lot of vegetation like plants, there's lots of roots. Those roots act like sponges to soak up and hold water. So slowing down runoff, plants and roots, therefore, will help prevent the loss or erosion of soil. So wetlands, forests, prairies, they capture and store more water than paved roads and parking lots. So therefore, urban areas, they're going to have more runoff than areas that are covered with vegetation. So this is just showing a diagram here. We have gentle slopes, lots of vegetation, so there'll be little runoff and erosion. Here, there's lack of vegetation, so therefore it can lead to severe soil erosion. Next is deposition. This is when the eroded material gets dropped off or left somewhere. So rivers, they carry water downhill from the land and back to a lake or ocean, but as it flows, it's also eroding materials from its bottoms and banks. Where the river slope is flatter, the river will slow down and deposit those materials. The volume of water flowing in a river determines how the river shapes the surrounding landscape. So if we look at here, this is fast moving water. It's created like a V shape valley. This one, this broad, wide river, it's got a more of a level floodplain. All right, so the volume of water flowing in a river will determine how the river shapes the surrounding landscape. The speed and the timing of the flow will also be factors. Rain flow, snow melt, groundwater, they will all contribute to the volume of flow. And stream flow will vary from season to season and from year to year. River flow monitoring, so stream flow, that's the amount of water that's discharged by a watershed. It involves measuring the amount of water, its volume, that flows past a certain point over a period of time, that is its velocity. So there are managers, watershed managers, they are measuring the amount of water flowing through a stream channel over a period of years to calculate its average stream flow. It's measured in meters cubed per second. This helps scientists to analyze water quality, also to prevent or warn people about floods. It helps them predict drought conditions. It helps them design irrigation for farming and agriculture, as well as drainage projects. Sediments that are carried by water, they have a variety of effects. This is just showing a cross-section of a stream channel. We can see the erosion, we can see sediments rolled on the bottom, as well as some suspended sediments. So why is monitoring sediment important? It plays a major role in the transport of pollutants. So any toxic chemicals, they can attach themselves to those sediment particles. Those sediment particles then will transport and deposit those toxic chemicals in other areas. So scientists and engineers, they can determine the source of the pollutants and then assess the impact of the pollutants on the aquatic environment. Deposition of sediment in rivers or lakes can also decrease water depth, which can make navigation difficult or impossible, as well as other problems as well. So how can we reduce erosion and stream sediment load? So there are desedimentation sites that can be built to prevent the sediment from entering waterways. For example, rivers such as the Fraser in BC, they're dredged from time to time to deepen the riverbed that's clogged by sediment. Planting native vegetation along the banks can stabilize the soil. That will lead to less erosion of the banks and therefore less deposition. Where the erosion is severe, it might be necessary to reinforce the banks with logs or other obstacles to decrease the current along the bank. So one of the major functions of wetlands, it is to reduce erosion because they store excess water, they slow the rate of runoff, they also trap and neutralize any harmful chemicals that are in the runoff. All right, so we're going to pause here. I have a video to show. So next topic is focusing on groundwater. We'll talk about watershed management and groundwater. So more than 25% of Albertans, they depend upon groundwater for their water supply. So things like wells and so on. Agriculture, irrigation, domestic use, and livestock, they all depend on groundwater for their water supply. So a groundwater system, it has connecting pores. There's two terms here we need to know. The first term is permeable. Second term is impermeable. We did talk about these terms as well when we were looking at cells and systems. So permeable means it's a substance that allows materials to pass through. So for example, soil and rock can be permeable if the pore spaces are connected and water can pass through them. An example is sandstone. Sandstone is permeable to water. Impermeable is when a substance does not allow material to pass through. So an example is clay. Clay has very small pore spaces or no pores at all. So it's very it's impermeable to water. Next, we're looking at an aquifer. This image here is showing a cross-section of a groundwater system. So we can see the aquifer is labeled right here. So an aquifer, it's an area of porous rock with a water system flowing through it. So some types of rock, like sandstone, they're full of pores and they can hold a lot of water. And then as every space in the rock becomes filled, the groundwater will form a sort of underground river system, but it's connected by pores instead of stream channels. We can also see like these two layers are permeable. This layer here is impermeable. We can also see the water table right there. This is the layer of porous rock in which all the pores are full of water. So it's in the ground, it's the level beneath which the porous rocks are saturated with water. So wells and springs. In this image here, we're looking at a well, how it's been dug deep enough to reach a point just below the water table. And then this area here is the aquifer. So in almost any part of the world, even in deserts, a hole is dug deep enough which will reach the water from the reservoir under the ground. So wells, these are made by drilling a hole through the soil and rock to a point below the water table, right about there. In some areas, the groundwater will just start to flow naturally out onto the surface. That is called a spring. So it's usually where the water table is exposed by a dip in the land. Some springs produce steaming hot water, like hot springs. They will occur where the groundwater is heated by rocks that have come in contact with molten material under Earth's surface. And then you may have heard of geysers as well. I think we'll talk about those in a little bit. When too much water is withdrawn for cities, for agriculture, or for industry, these precious reserves can be depleted. So aquifer depletion. So creeks, springs, and wells for kilometers can go dry. And then people, they have to truck water in or they have to build pipelines. Local plants and wildlife will also be affected because they will be left without enough water. Groundwater can become contaminated. Contamination is any addition of undesirable substances to the groundwater and is caused by human activities. Two categories of sources. Point sources. These are when the source of a pollutant is from a small defined area. So for example, there's a leak in gasoline storage tanks, or there's a leak in septic tanks, accidental spills, landfills, industrial waste disposal sites. Those are called point sources. Non-point sources is when the pollutant comes from a wide area. For example, runoff from farmland, if it's been treated with pesticides and fertilizers, that would be a non-point source. Okay, so two types of categories, how groundwater can become contaminated. Point source and non-point source. Right, this is a landfill, a municipal landfill. That would be a point source of groundwater contamination. Too little water. So in the south, Alberta's rivers, they carry smaller volumes of water, but the agricultural, industrial, and municipal demand is very high. So some river channels are in danger of drying up during those hot summer months. Too much water. If spring melting occurs very, very fast, together with a lot of heavy spring rains, there's large volumes of water that can enter a river channel in a very short time. A river may then overflow its banks. It can spill out over a wide area of the valley floor. A floodplain, we've seen before, it's that area that's bordering a river or stream. It's generally a flat area of land, and it's naturally subject to flooding. It's made up of largely soil deposited by floods. So it's there for protection. A river that overflows its banks can then bring disaster if cities, homes, and farms are built on those floodplains. Dams. This is showing a hydroelectric dam at Ghost Lake, Alberta. So they're built for many different reasons, including irrigation and flood control, here in this diagram is for electricity. So large dams, they may just be used to supply water to a city. They can also be used to generate hydroelectricity. A dam may be placed across a river for storing water for the dry southern Alberta summers. The constancy of the altered river often reduces the diversity of organisms that were present before the dam was built. So there are these disadvantages of building dams. It affects the ecosystem, it affects the environment and organisms that were living there before that dam was built. Here we have a quick video, not a quick video, this is a site I'm just going to quickly show. Calgary's water supply, where does our water come from?